Welcome to June 12th LeetCode Challenge. Minimum number of refueling stops. A car travels from the starting point to a destination which is target miles east of the starting point position. Along the way there are gas stations. Each station I represents a gas station that is station I at 0 miles east of the starting position and has stations I at 1 liter of gas. So this means that basically when you travel from point 0 to point 1, you use up 1 liter of gas. Right. So the starting position has, the car starts with an infinite tank of gas, so you can store as much gas in there as you want. Initially has starting fuel liters of fuel in it. So it uses 1 liter of gas per 1 mile that it drives. When the car reaches the gas station, it may stop and refuel and transfer all the gas into the station of the car. So it can stop, but it doesn't have to. It could reach the destination, but it could not. It may also not. You can also not refuel if you don't need it. So what's the least number of refueling stops the car must make in order to reach its destination? If it cannot reach the destination, return -1. Note that if the car reaches a gas station with 0 fuel left, the car can still refuel there. If the car reaches the destination with 0 fuel left, it's still considered to have arrived to its destination. So here's some example. You have the target destination of 1 mile, and you have a 1 liter of gas in your car, in starting fuel. You have 0 gas stations here. So what that means is that you're able to travel from point 0 to point 1 in 1 mile using 1 liter of gas, and you get to the destination, your target. So we can reach the target without refueling. So the result output is 0. You don't need to refuel. Let's give example 2 here a try. We have a target of 100 miles. We start off with 1 liter of fuel. So obviously we cannot reach 100 miles using 1 liter of fuel. However, we have a gas station here. However, the gas station is located at 10 miles away from the starting position. So what that means is that we're not able to refuel at the gas station either. So therefore, we have to return -1 because we can't reach our target destination or even the first gas station. Let's go to target number 3, example number 3 here. We have a starting target of 100 miles. We start off with 10 liters of fuel, and we have 4 gas stations along the way. So here's how it goes. You start from position 0 with using 10 liters of gas. You travel to position 10, right? So 10 miles east of your starting point. So from here you want to refuel because your gas right now, you start from you had 10 at 0. You drive all the way to 10 and you consume all your fuel up. Then you have 0 at this point. So then you want to refuel at position 10. So now you have 60 liters of fuel. So from here we decide to go all the way to past this gas station, and then we go to point 60. So from 10 to 60, we have driven 50 miles. Therefore, we're going to use up 50 liters of gas from our 60. So therefore, when we get to position 60, we have 10 liters of gas left in our tank. However, in order to travel to another distance, we need to refuel at position 60 right here. And we're going to refuel with 40 liters of gas. So that means we're going to add our 40 liters of gas to our pre-existing 10 liters of gas to give ourselves a total of 50 liters of gas at this point. And then from there on, we can travel to 30 and 20 without needing to refuel in order to reach our target of 100 miles. So yeah, that was a long, lengthy one. This question is obviously labeled as hard for a reason. So my first initial thought is there is a way to solve this using a dynamic programming approach. I'm not very familiar with that method at the moment, but another way of solving it is using a maximum priority heap or maximum queue priority queue. So you're going to use a max heap approach to it. So think about it this way: if you have a tank of gas and you could travel to across a gas station, you don't have to refuel at that station. you could pass that station and then go to another station that you're able to get to without consuming the fuel at that station. What if you pass a gas station that has a good you don't know if you need to refuel or not until you reach the next destination, if you can or cannot. So it'd be a good idea to store the capacity or the fuel capacity of the gas station in a maximum heap, so that every time you will always have the most optimal amount of gas to refuel from your previous I guess, passing of the gas station. So that's kind of the initial thought about it, and we're going to store our gas stations, or stations I should say, within a max heap, so that we could, every time we go to a station that we need, every time we go to a location that we cannot target, that we cannot reach, we will look back at a priority queue, and then we're going to grab the last station we've been through that has the highest amount of gas in it. Right? Therefore, we're going to maximize or optimize the amount of the minimum amount of gas stations we need to reach to, because we're taking the gas from the highest gas station that we have previously gone past by. So let's start off with creating the priority queue to begin with. So say PQ equals the array there. Then we want to store the number of times we visit a gas station or refueled as say results, or stops, or results. And then we want to store the index of the location that we're at, the location of where we're at, the location of the gas station as well. So we start off at 0 on the furthest, at the most west we can go. So when do we need to refuel? We want to refuel while starting fuel is less than our target, right? Because we only need to refuel when our starting fuel is less than our target destination, because we don't have enough gas. So when that happens, we also need to refuel while, so in order to, for this, so we need to refuel, we enter this while loop where we need to refuel. So next, how do we know which stations we've been, how do we know what gas stations we have crossed so far? And how do we know if we're able to access the gas station or not? So we want to be able to access the gas station while the index you're on is less than the length of the gas station, I should say. So if the index you're on is less than the length of the station, because that means you haven't reached that station yet, and the station at I0 is less or equal to your starting fuel. So when this happens, it means you have crossed a station previously, and when you cross a station previously that you haven't refueled at, you want to store that into your heap. Let's see, heap push. You want to store that in your priority queue. Here's a quick tip for you guys. If you put a negative right here, that means you're changing from a min heap to a max heap. That's a cool trick there. And then you want to increment your position as well. However, if it's not in your priority queue, then return -1 because you can't reach a gas station that you haven't crossed by yet. And then, so this is if you have access to, if you have gone by a station and you haven't used their gas at the station yet, so you haven't refueled yet at that station, but you have it in your queue. And then the next thing you want to do is, so if your start fuel is less than your target, that means you need to refuel. Then you're able to access the gas stations you have crossed before. So when that happens, you want to be able to access the station that's with the highest amount of gas in your queue. So in order to do that, you want to refuel. Here's your refueling step. So you want to add the fuel by popping off from the heap. So the heap pop. You're from your priority queue. And then you want results to increment 1 because you are refueling. That's one of your refueling stops. At the end of the day, you want to return your refuel, your minimum number of refuel, so results. Let's run the code and see if this works. Finish 0, 0. Well, that's not really helpful, but let's submit it. Oof. Let's see. What am I doing here? Oh, stations. Please work. Parentheses. I have a square bracket. What? Come on. Oh, I have insert on. Please work. What am I doing wrong? Start fuel stations. Start fuel I results. Increment 1. Right here. Yeah, you want to pop from the top of your max heap. Yeah, that was mine. Okay, accepted. Oh, that was a tough one. So this would be the time complexity would be a big O of n log n, because we have a while loop within a while loop, but we're only accessing n amount of stations, and the rest is just basically the log of n. So every time the n is our target destination, and the log n part is the number of stations we have crossed. Time complexity is big O of n, because we're only storing the number of stations within a priority queue, and that's all. That would be it. Yeah. So this number of stations that we have for space complexity. All right. That's pretty much it. It's a tough one. I hope you guys get it.